Hi, my name is Matt Sheehy, and I'd like to tell you about my Hovercraft project. So it started off in my after-school club called SMILE. It stands for Science, Math, Investigating, Learning Experience. And in that club, we do a lot of engineering challenges. And every week we have a different engineering challenge. And the one for 1 week was building a hovercraft using a CD and a balloon coming out of that CD, and when you blow up the balloon, the air want to go through the bottom of the CD and cause it to hover, kind of like a hockey puck on a air hockey table. And so this really intrigued me, and I actually did not do very well in the challenge at all. So I went home and started to build my own kind of hovercrafts. So my first hovercraft was this little guy. Or one of my first, but one of my first ones was this, made out of just some simple cardboard, plastic trash bags, and I put a little CPU cooling fan right here to try to make it fly or hover a little bit off the ground. It worked a little bit. I decided certain things were wrong with it and made some improvements. So my next hovercraft was this guy, and I used another CPU cooling fan. This one's a little bit bigger, and it would blow up the hovercraft again and make it hover around. It worked all right. It's not a real skirt, it just used some trash bag, some holes in it, so I made yet another one. This was one of my final designs using trash bags and a bunch of house scraps. Like I have cardboard, and like I said before, I have all this plastic rebar and stuff in this thing. And again, CPU fans. I used 2 this time to make it more powerful. I kind of took it apart, salvaged the parts. I used to have some resistors on here, some potentiometers to make the whole thing work correctly. Did have a giant back-powered fan here too. It worked pretty well. It could move around a little bit, but it had a tether, so it was plugged into the wall and stuff. But after this, these guys were done, I started doing some actual research online on how to build hovercrafts and different things that are out there. And so I started looking at model airplane parts, or RC airplane parts. So I discovered things like high-powered motors and electronic speed controllers and lithium polymer batteries, and these are a lot more powerful than the CPU cooling fans, so I'd get better results out of them, out of the hovercrafts. And I also discovered things like servos, which you can have control arms running off of them, so you could have all sorts of different kinds of rudders to steer your hovercraft, or anything you want really. And so that's when my imagination really got going, and I really started building some interesting. This is my first fully functional model hovercraft. It's kind of taken apart right now because I had to use the motors and electronics in different hovercrafts. But the way this one works, or this one did work, was air would be pulled down by a motor underneath here into this ducted system. And the way the ducted system works is that there's just a gap between two of the bases, and the air can blow around all the way around the edge of the hovercraft out of those gaps, and then fill up the bag skirt. And once the bag skirt's filled up all the way, the air can leak out of these holes in the bottom, and then the air is more pressurized in the bottom now. It wants to come outside the hovercraft, so it'll slowly curve around the bags once they're blown up, and that'll give you that frictionless effect on the ground. Also, we would have a fan in the back to make it go forwards, a propulsion fan, and we'd have rudders in the back here with a servo that would make you steer the hovercraft. And I also added this special fin in the back to allow you to raise and lower the back of the hovercraft when the motor's going. It didn't work that well though. So this hovercraft is made out of EPS insulation foam. This material worked alright for the base of the hovercraft. The only issue is that it's very flexible, and when you try sanding and working with it, it often breaks off into big pieces, and it's really annoying to work with. A lot of this hovercraft's also made out of metal flashing. This stuff is also not the best building material because it's very heavy, it's sharp, and hard to work with. Another issue is what I did for the skirt. The skirt's made out of a canvas painter's tarp. It worked pretty well on land, but instantly when it gets wet, it sticks to the ground. And also, since it's so big and there's so much surface area, it creates a lot of friction, so it can't move around as easily. Although this hovercraft worked pretty well, I still wasn't completely happy with it. So I met with an engineer that did a lot with model airplanes and whatnot, and he gave me a few ideas. Using those ideas, I made this hovercraft. A little bit nicer than the other one. So some of the things he told me to do is use a different kind of material for my base. And so what he told me to use is called extruded polystyrene insulation, and it's a lot better than the old stuff because it's much more stronger and it's easier to work with because you can sand it nicely and it turns into these nice curves. So this whole entire hovercraft is made out of this insulation. It's painted white, that's why it looks a little bit different, but it's lightweight and it works really well. Also, I try to stay away from metal flashing because it's really heavy. There's only one place right here that still uses it for the control arm to the servo. Another thing that he told me to do was to smooth down all my edges to reduce air turbulence. And so you can see all the sides of the hovercraft are nice and rounded. All the intakes to the propulsion fan and downwards fan are all sanded over to really want the air to go in nice and easily and come out nice and easily in the backside. Also, all my motor mounts and fins in the back are all made out of balsa wood, which is a lot lighter weight, just pretty strong too, and it's a lot nicer to work with. As you can see, this hovercraft looks a little bit different than the other one. That's because it works a little bit differently. So instead of having the two hulls and having the air go through a little like duct, this one, the air can go directly onto the ground through that fan. There's no two separate bases or anything. And instead of using that really bad tarp or canvas painter's tarp, I'm using a inner tube that's cut in half with some Velcro on it, so this whole entire thing can be taken off and replaced if it ever got broken. This also works a lot better than the canvas because it doesn't soak up any water and it has a lot less friction because it's a lot smaller edge. Also, this hovercraft is almost entirely able to be taken apart and replaced. Like the whole entire back end of the hovercraft can be taken off and replaced. Also, the whole entire back of the motor mounts back of the fins can also be taken out and replaced if they ever broke. As you can see, this hovercraft also has something different up front. This is called a ducted fan, and its purpose is to stop the hovercraft from spinning around in circles. It's kind of like the tail rudder on the back end of a helicopter. And so I made it myself. The whole thing can spin. I'm using some Lego pieces and a little servo down here, and that can let it spin remote controllably, which is pretty cool. And then I can use that the spin to get the counter rotation just right so it can hover in one straight spot. Also, I can use it to make the hovercraft go backwards or move it more easily rather than using the big powerful fan in the back. Unlike all my other hovercrafts I showed you today, this one actually works. So, yeah, I've actually added some cool LED lights to make it easier to see where the hovercraft is. A little bright. So we got some up here, some around the edge of or front of the hovercraft, and then some little blinkers in the back, which are pretty cool. So up front, we have our ducted fan that can turn almost in a 360, not quite. And we have the controls to turn that one on. We also have our downwards fan right here we can turn on to generate lift. If I want to go too high, it'll come flying off the table. And we also have our fins in the back for steering, and we have the thrust in the back to make it go forwards. So this is my newest hovercraft. It's kind of taken apart right now because I used the parts to remake the white one because it works a little bit better, or as of right now. But so this one has two downwards fans that would go here and here. Works very similar to the last one. Has a skirt in the bottom. The skirt's not made out of an inner tube. It's made out of a bubble wrap, which I think it might work better because it's a little bit lighter weight. We also have two humongous ducted fans up here in the front, which are both incredibly powerful. So my idea for this one was to try to make it go as fast as possible, but I kind of messed up some of the wiring and kind of blew up some of my stuff, so I can't make it run right now because I need to order new parts. But I want to try getting around like maybe 20-30 miles an hour. I'm not sure if it's possible, but I'm going to try. What started as a simple 15-minute engineering challenge at my local science club turned into a 6-month passion of building hovercrafts. This eventually brought me to the state science fair, where I got in the top 10 and received awards from Raytheon, the Office of Naval Research, and the Yale Alumni Association in recognition for my innovative ideas. I learned a lot about the engineering process and learned about using the right materials in the right spots can help make your hovercraft a lot better, or whatever you're making a lot better. However, I'm not done with building my hovercrafts. Like I said before, I'm still working on this new one. I'm using 2 rotors that would help stop the counter rotation instead of using the ducted fan. And I'm also working with the Arduino microprocessor to work with a gyroscope to help to control the hovercraft better and keep it more stable. Thanks guys for watching. Hope you enjoyed it. If you have any questions, feel free to leave them in the comments below.